Hello ladies and gentlemen, welcome back to the lab. We had our first iSkills hangout last week. We discussed a situation where a guy had damage as a child to his cornea, and the cornea is the layer of transparent, tough skin over the eyeball. And he described it as a bit like having a bug on a windshield. You just can't see properly. The issue is that at the back of the eye, you have your retinal cells. So those cells are stimulated by light coming in, photons, and they create an electrical signal which goes back into the brain and is processed by some magic inside this thing, through which we have the conscious experience of sight. Vision is really mostly in the brain. And in his case, the most useful part of the eye with the highest density of neurons for perceiving light, so in other words, being able to see with very high resolution, the fovea, isn't getting anything useful because there's scar tissue at the front of the eye, right in front. So he spent all of his life kind of seeing with his peripheral vision, trying to move an eye slightly off center, if you like, to be able to look around the bug. So now, very late in adult life, he's had surgery, a corneal transplant, which is actually where they've cut away the damaged tissue and sewn new tissue back on. And now we have a pretty typical situation in amblyopia, where one eye has had an optical problem of some sort, and there are so many causes, in this case the scar tissue. So the visual system's basically got used to no useful information coming from the fovea. It's got used to ignoring it. It's not really learned, or it's forgotten how to integrate information from the fovea with information from the other eye. Or maybe it's just not even really perceiving it. We didn't really get into enough detail there. So I thought about this a little bit, and we had a chat, and this guy's a better software engineer, a better programmer than I am. But I thought, again, with Pocket Code, I'd just show that it's possible to put something together very, very quickly that could potentially be useful for specific cases. In this specific case, the goal is to try to reactivate his fovea, in other words, his brain's perception of the fovea. He's got peripheral vision, but can we somehow stimulate, gradually, incrementally, strengthen his connection to the fovea now that his fovea is getting useful information because the scar tissue has been removed from the cornea? So this is the little game I came up with, and this is really, really version 0.00001. Let's have a look at it. It's composed of only a few parts. A ball and something that flashes, basically. So let's take a look. This is actually still for me to debug. These two black dots, you shouldn't even see those anymore, but it doesn't matter. There's this red ball that randomly moves around this central point. So the idea is that you have to follow it quite closely using your precision vision, because the goal is to hit this with your finger. Whenever the green square appears in your peripheral vision. Now the green square is supposed to appear just long enough that you haven't got time to look at it and look back and hit the red ball, because you have to hit the red ball while the green square is on the screen. So you have to use your peripheral vision and your foveal vision. So we'll do it. When the green thing appears, there. Oh, I missed it.
You win.
You win. Okay, incredibly simple. Now, something like this would perhaps, if it's useful, you'd start with a larger ball, moving more slowly, and the peripheral vision element, this green square, would stay longer to start with and be more obvious. But gradually, as it detects you're getting faster and better and stronger at seeing where the red dot isn't touching it, the usual approach would be to have a heuristic an algorithm which just gradually increases the speed, reduces the size of the red dot, makes it harder. Keep challenging, keep challenging, keep challenging, keep making the brain learn and grow and adapt. So I want to have a quick look at the code, just to show again. This is maybe, I don't know how long this took me, 20, 30 minutes with Pocket Code. Do we have anything in the background? Yeah, okay. But that's not relevant. In the ball, so the ball, we get an event, which is the program starting. So the ball is literally just a circular red graphic, and I have that black dot in the middle. I had that black dot in the middle to help me understand how Pocket Code is dealing with rotation. You'll see in a sec. So when the program starts, we set the rotation style all around. There's various options, only rotating left or right, or not being able to rotate if there's physics involved, but we say no problem, rotate in any direction. We place it on the screen off to the left, and then we get into an infinite loop, and we say always point towards the object called Dame. That's actually a spelling mistake. And until we touch that object, move 15 steps. So the circle is rotated to point towards the black dot in the middle of the screen, because that's where our Dame object is, and it moves towards it until it touches it. Then it points off in a random direction, point and direction random between 0 and 360 degrees, and 30 times move away from that black dot in the middle of the screen. So we end up with this red thing moving towards the dot, heading off in a random direction, heading back towards the dot, moving off in a random direction. So we have something which is constantly moving. It's a bit of a challenge. You've got to stay focused on it. And when it's tapped, so this event, when tapped, is received when you touch the red dot. If shown is 1, speak you win, else speak nope. Now what's this if shown is 1? Well, the flash object, when the program starts, forever, in an infinite loop, we start by hiding it, and we set the variable shown to 0, off. We wait between 1 and 10 seconds, because we don't want it to be predictable, and we place it at a random position across the top of the screen, because again, we don't want it to be predictable. And then we show it for 1.5 seconds. And while we're showing it, we set this variable shown, which is accessible to all of the other objects in the game, to 1. So in other words, if you touch the ball when tapped, and the green flashing thing for the peripheral vision is being shown, the variable is set to 1, you win. So again, super easy prototype. It doesn't make the game more difficult to play with time. It doesn't store results. It doesn't do anything. There's no calibration. It's not coptic. I forgot how to pronounce it. It's not splitting different parts of the game for each eye. It's just a proof of concept. What I really want to show is, when it comes to developing useful games for specific problems in strabismus or amblyopia, it could be worth looking at Pocket Code. So thank you very much. I'll show this to the relevant guy and see what he says, and maybe we'll develop it a little bit further.